that also requires you to have an understanding of the architecture underneath and the assembly language, so x86 or ARM. And if you're having trouble, just look at the strings and they'll give you lots of clues. So, you also want to be able to analyze the application while it's running. So, debuggers, tools like GDB on Linux or WinDebug, you need to know how to use those. Inspecting logs, I find, is also very helpful. The developers do take time to put in helpful log statements so you can kind of trace the application while it's running. And also just adding print statements, if you do have the source code, that can really help you as well. Most of the applications we look at are network-based, so being able to capture that traffic and analyze it with Wireshark or TCP dump, essential. And on the web side, Burp Suite is amazing. You can capture and modify traffic in transit. So we write proof of concept scripts for virtually every vulnerability that we find. So being able to write those tools and package up complex logic, like client-server communications, that'll make you more successful. And in addition to making yourself more efficient, if you can publish a tool and then release it, that'll make that next researcher more efficient if they're looking at the same kind of stuff. And fuzzing is probably one you've heard a lot about, finding memory corruption bugs and stuff like that. But just having an idea of how to feed an application random or malformed data, it's going to help you generate crashes. There are some frameworks that can help you with that, like AFL or Peach. And if you want something more custom, definitely go to like Python or your favorite language. So I'll hand it over to David.
All right, thanks, Chris. I'm going to go over mindsets and character qualities that are helpful for finding 0 days. We're going to go over 4, and while these 4 are helpful in anything you do in life, we pick these 4 because they're especially effective for 0-day research. And so the first mindset that's helpful is how you acquire your knowledge base. And knowledge base in 0-day research is almost everything. You have to know operating system internals, programming languages, encryption methods, file formats, and also mitigations and ways to bypass them, and actually vulnerability classes you can trigger. So it's an enormous landscape, and one attribute that can help you expand your knowledge base is just having a curiosity. So if you're someone who likes to figure out how things work or read other people's research and how you can apply it to yourself, this is a great trait to have for 0-day research. Now, but just having knowledge base is not how alone is good enough. You also need to actually find the bugs. And this is where attention to detail comes in. It may be thousands of lines of assembly you're looking at, and it might be just one instruction, an unsigned comparison, that's your integer overflow you need to find. So this is a level of attention to detail you sometimes have to have in order to spot these very subtle bugs. Another way of saying it is, when it comes down to attention to detail security-wise, you have to have more attention to detail than the developers and the code reviewers had before they push their code to production. So it's very important. The next trait one I go over is just intuition. And this comes with experience, but it's what will allow you to focus on certain things and not so much others. And it'll improve your efficiency in turning over 0 days and bugs and applications. So a good example is sometimes you might see the inner workings of an application and how various components are interacting. And it's your intuition that can say, I feel from my experience and how these things work, I feel like this section of code is vulnerable. And you can just focus on that first and start attacking the application. It's also what helps you improve your reverse engineering speed. A lot of reverse engineering is a hybrid of manually reversing and also just kind of intuition of saying, oh, I think I know what this function does. This is huge. And finally, I'll end with persistence. Again, important in anything you do in life, but in 0-day research, it's especially important. Especially when we're in an era where security is more practiced, and oftentimes your target has already been looked at by other researchers. So it kind of becomes a war of who is persisting more to uncover untapped code base. I'll end this one with a story. I'll go at the end here. We'll go over some actual bugs we found, and the one I'll go over is Zoom. And Zoom was very difficult. I spent probably 3 weeks on it, finding nothing. I tried SQL injection, tried fuzzing the protocol, all types of attacks, and I had the decision to either persist or just give up and move on to another target. And one thing that helped me was I just reframed it by saying, do I know enough about the target that I can prove exactly why it's not vulnerable? And once I asked myself this question, it helped me with my persistence And I literally went through and I would go, well, it's not vulnerable to SQL injection here because the sanitization routines are called here, here, and here, here. And as I went through, it really broke the surface and bugs started to come. So this is just a way to balance persistence. Obviously, you can't go too far with it, but that's a great boundary to ask yourself if you're truly done, is ask yourself, am I familiar enough with the target that I can prove exactly why it's not vulnerable? So that's all.
So I'd like to talk about the research process. So our first step is to select a target, right? We consider a few different criteria. We'll look at well-known vendors like Verizon, new cutting-edge technologies like Arlo or Zoom. And as Joe mentioned in his previous talk, SCADA, it's a hot topic, right? We also like to look at popular or ubiquitous types of systems like Windows or Mac OS, or something more niche like Microtech. But ideally, the goal is to produce something meaningful at the end. So if we can't get our hands on the target, we can't research it. So we will have to select new targets sometimes. And a reason we might not be able to get a target is because it's too expensive. Maybe we don't have the budget for it, or it's a large physical device. Or maybe we just have to jump through a lot of hoops to get our hands on it because we're dealing with salespeople and more stuff than we want to deal with. So here's an example of a Tesla. That's kind of our joke on the team. We really want a Tesla. But unfortunately, it's very expensive, and where would we store it, right? So that one's kind of making us sad at the moment. Another example, I was just trying to get my hands on a 30-day trial, but instead of getting that download link in the email, instead I got a sales type of thing. So I had to jump through some hoops in order to get the target. So that's another reason I had to end up getting a new one. Ideally, we want a free download, 30-day trial, or something within budget that we can license. So once we get our hands on the target, then we can set it up, right? And this is where the virtual environments come in. So we can take snapshots of whatever we want. We can set up Docker containers, virtual machines. So for every different type of target, like whether it be a Windows or Linux or Mac OS, I'll have a base research environment set up. So that's a snapshot, right? So I have that research environment set up, and then I'll install the target on top of it. So I always have my tools underneath of the install. So I've listed out some tools I use for Windows, but I really love Visual Studio. Just have a good IDE to look at code and compile. IDA Pro, Burp Suite for the web, and have a debugger on hand. And another thing that might not be as obvious is just make sure you understand the system requirements for your target. Some of them require lots of memory, maybe more than your machine has. Maybe they require lots of processing power or more storage than your environment has. And keep in mind the dependencies, like different libraries and stuff. Some targets are a pain to install, so just make sure you know what you're looking at there. And I mentioned snapshots. Those are probably the most important part of the process. I mentioned the base research environment that you install on top of. Take a snapshot there. After you set up your target, snapshot that so you have a fresh snapshot, fresh install. And if you think you're going to do something that might clobber your target, like mess up configuration files or whatever you can think of, snapshot before you do anything like that.
All right, so Chris just talked about setting up your target and getting it configured, and now's the part where we want to start tearing it apart and looking for vulns and all the fun stuff. But before you start tearing your application apart, it's really important to find your attack surface first. And you can find your attack surface in your target by asking yourself two questions. One is, what are the privileges of the running target? And two, what components of the target cross into lower privilege boundaries? This will apply to finding like the Spectra meltdown vulns or a SQL injection across the web. It just depends how you frame these questions for your target. And it's important to understand your attack surface before you start tearing it apart, because you might realize that 90% of your target is not applicable for zero-day research. And by just honing in on the attack surface that's applicable for an attacker, you cut down your analysis time extreme. So very important to first find your attack surface. And I'll go over an example here. This is basically an example of what you'll come across in any target you investigate, whether it's an IoT device or an application. What we have here is an operating system with various privilege boundaries within it. and might be connected to an external data source. In this case, internet, but it could be Bluetooth, USB. And if we take Discord, for example, well, ask yourselves the first question, what privileges does Discord run as? Runs as default user, unlike Linux and Windows. Okay. So now second question is, what components extend into lower privilege boundaries? So what are our lower privilege boundaries here? Well, we got sandbox, container environment, or just the open internet. So right there, that's our lower privilege boundaries we need to focus on. And so now we just need to find components that extend into that we can reach from an attack surface. And what do these look like? Well, these components are things we're all familiar with. They're like, they can be files, network sockets, devices, name pipes, shared memory, RPC, basically interprocess communication technologies there, USB, Bluetooth. It goes on and on and on. So if we do that for Discord, like for example, what components can we extract from Discord that are interesting for zero-day research? And we do that here. We can see, like on the internet, it might be listening externally for text and video to be processed through this port. It can process hyperlink clicks from the internet. You can craft a Discord protocol handler and get Discord to trigger with a malicious argument, perhaps. So that's something to look at. And on the sandbox container environment side, like on a low privilege boundary on the operating system, Discord has like a local service listening on local host, and maybe from a sandbox container you could talk to that and get a sandbox escape to occur via Discord. It also might have exposed shared memory objects with no protections, or again hyperlink clicks. So this is an example. We just tore apart the most interesting components, so we just need to look at this now. And what do we do now that we found an interesting component? Well, there's a few options here, and Chris mentioned fuzzing. So yeah, fuzzing's definitely one of them. There's also, go through disassembly or debugging. And I'm going to go over the pros and cons of each one of these. And these are more of my personal pros and cons I found. So starting with fuzzing, as we know, Chris mentioned, it's like the brute forcing component with arbitrary input. And the pros of fuzzing is they're good for large and complex components. I think of things like scripting engines or graphics drivers, just very painful to reverse, but fuzzing can really help supplement that and automate that process in what we call code coverage, getting good code coverage with your testing. It's also good at finding more obscure memory corruption related vulnerabilities like UAFs, double free, type confusion. Some of these are so obscure, like you might need to create 3 objects of this, free the middle one, then sort the 2, and it's like a race condition that does some type of heap exploitation. Like, the human mind might not be very good at spotting this when you're disassembling or reversing. So fuzzing is great for attacking this and finding these very obscure memory corruption vulnerabilities. But fuzzing does have some real cons to it. One is that it must be context relevant to get proper code coverage. So going back to my scripting engine example, if you want to fuzz a scripting engine, you'd have to know all the keywords, you'd have to syntactically put them in a reasonable order, or a graphics driver, you'd have to know the right ioctals to hit with the right parameters to get code coverage in the driver. It can turn into a big reverse engineering job, which kind of defeats the purpose a little bit of fuzzing once you actually understand it. So that's a con there. And it also is not really good for finding logic flaws. So logic flaws is because with fuzzing, you need instrumentation to tell you that something broke or went wrong. And logic flaws are notorious for being subtle and not screaming at you that something just went wrong. Like think of path traversals or things like that. And so if you're looking for subtle logic flaw type bugs, fuzzer it's not really the best tool suited for that. So moving on to disassembly, this is one that I kind of personally favor, but it does have some cons too we'll go over. Well, one of the pros is that XREF ability, right? We talk about hunting for components. If we want to immediately find where that component is handled when this big application of Discord, XREFing is so great. XREF on the receive API, and you find right where it's receiving network data, and then right after that, how it processes that. You're like instantly there. It provides precise understanding of functionality. This is because there's no more guessing. You're actually looking at the code and seeing the code paths and interesting things you can hit. It's also, of course, good for finding logic bugs because of this. You're using your human brain to really churn through the logic branches and seeing what you can hit. But the cons, of course, are like brain must emulate hardware. Sometimes disassembly, when they're using a lot of like indirect calls or push pops in the stack or it's obfuscated, you have to turn your brain into an Intel processor, which I haven't done yet, and it can be pretty hard. So maybe not the best for those types of situations. And it may miss more complex and obscure memory corruption vulnerabilities. Of course, like the example I just gave, trying to spot some really obscure heap corruption vulns that you could hit through static analysis, like that can be pretty tough. Finally, moving on to debugging. Pros here, it can identify actual crash types and locations. I mean, ideally, you want to combine a debugger with fuzzing so it can tell you what just happened and what line just went wrong. It works well against obfuscated and packed code. This is because the unpacking or deobfuscation process will happen in the debugger environment, and you'll actually have introspection into the raw code once it's deobfuscated or unpacked. Provides seamless inter-library call support. This is something disassemblers are not good at. A lot of times these, especially in vulnerability research, you'll see a lot of inter-library calls happening with other DLLs that the application has. And when it calls into it, you can seamlessly step in, step back out of it, opposed to disassembly where you just see a symbol and you don't know what it does. You have to open another IDA instance and look at that DLL. So provide some slick maneuvering there. The cons, though, of course, is not good for XREF, and it's clunky to navigate, and in general, it's just not a viable standalone tool. Debugger is something you want to supplement with, not use, replace. Okay, so now Joe will talk about finding a bug and what you do.
All right, so say you just turned your brain into an x86 central processing unit and found a bug. Now what? You did all the work already, right? So to handle it now, always double check your findings. Start with that. Make sure that you can reproduce your results, revert the snapshot, use a default install on the application, check it again. So you want to document everything. The versions that you use, post-install configuration changes, additional modules that you had to install. You want to be really thorough before reporting to the vendor. And the reason for that is that your credibility is a major driver as a discloser to the vendor, which is going to determine how they respond. So you see researchers get blown off all the time by vendors. They don't care about security, they don't want to fix it, they just don't want to spend time on it or money. So it's very important to be accurate and correct, because if you're wrong in your initial report, it's going to be extremely difficult to convince a vendor that your finding even matters. So just check it again before you send it. After you verify your finding, you need to clean it up. Whatever tools or scripts that you used to prove the vulnerability exists, you want to get them finished and as clean as possible. Minimum subset to prove your vuln. When documenting your tools or steps to reproduce a flaw, be specific. For example, cross-site scripting as an example. Document the payload. Put the exact URL, any options or headers that are required to produce it, any type of configuration that's needed for the vendor to reproduce it. And so documentation is really helpful here. Screenshots are really helpful. As another example, if you're reporting some type of memory corruption, privilege escalation, you need to provide an additional executable in your proof of concept to the vendor. Be specific in how the tool is intended to be used. So the tools that you provide, they don't have to demonstrate the most severe impact, but they need to demonstrate an understandable impact. And they don't need to be perfect either. The vendors are not expecting some production level application just to demonstrate a POC, but it needs to at least be reliable. So you need it to do exactly what your documentation states as perfectly as possible. And there's always some subjectivity to that, but you at least want what you send to the vendor to work. At this point, write everything up. Take your time, go back through your disclosure, chop off any unnecessary information, be brief but be specific. The person that's triaging the report at the vendor is probably not going to be familiar with all the ins and outs of every single product that they have. So it's best to be specific at first and broaden reporting later as disclosure goes on, rather than overwhelming all at the beginning with a ton of details. And so now we'll talk about actually disclosing the finding. So there's a few different types of disclosure. Private disclosure would be selling your finding to someone that doesn't really care about protecting people and is not going to publish the details, Zerodium. Public disclosure, on the other hand, is publishing your research before giving the vendor a chance to review it. So just dropping the exploit on GitHub and saying, here it is. There's a ton of pros and cons there, but we're not going to go into that. So in general, we advocate for coordinated disclosure, where you tell the vendor what's wrong, give them a chance to fix the issue, and tell all their customers and users, and coordinate your publication with them. We wrote a 90-day disclosure policy. Starts on the day that you inform them about the vulnerability. And then they have 90 days to fix the issue before we go public. Sometimes they make it most often they do make it. Sometimes they don't. We publish and there's no patch. So if a vendor is unresponsive, we'll inform CERT at the 45-day mark and then publish pretty quickly after that. But we almost always work with the vendors throughout that 3-month timeline to provide clarification, to help them out with other issues that come up, just clarification and communication issues, and as well as to monitor the fix as they're progressing on it. And our policy also has some leeway in there for us to be flexible with vendors that are clearly trying in a responsible way to fix the issue but are just not going to meet that deadline. So we can provide extensions if needed. And then, as I already mentioned, bug bounties have pretty well-defined procedures as well. So if you're reaching out directly to a company, find a security contact before you disclose. A lot of the times you can't find one, and you can first maybe reach out to sales, information, support, or whatever. But if you end up disclosing your vulnerability to a non-security contact, they're probably just going to, there's a 90% chance they're just going to ignore it. So once you've sent the disclosure, the bulk of the work's done. In most cases, you want to follow up during that process, just keep tabs on the patching progress, and it's going to let you know when it's safe to publish your findings. So, and also what you can expect as far as bounty payouts and stuff like that. And it also is going to ensure that someone else on the other side is actually paying attention if you're pinging them every couple of weeks or so, and they're not just ignoring the problem. And then 10 days before the disclosure's up, they're like, oh no, what do we do? So, all right, so now we'll cover some of our own research, and we'll talk a little bit about some of our findings and just general overview of our strategy.
Yeah, so we'll first talk about Citrix SD-WAN, formerly NetScaler. So SD-WAN is software-defined networking. The goal is to replace traditional infrastructure like routers and stuff like that with software. If you check out the topology diagram, at the top node is SD-WAN center, and then beneath that, you'll see 3 nodes. Those are all appliances. So there are 2 different types of nodes in this diagram. The SD-WAN center is more like the head end of it. It's the brains of the operation. It's going to talk to the appliances and all the various components in the network. However, the SD-WAN center and the appliance both have web interfaces. So that's what I looked at. Setting it up was pretty simple. You just download a virtual appliance, run it, no config required. The only problem is the source code wasn't readily available. So, like you'll see that when you log in, you're presented with a limited shell, not the expected bash shell that I hoped for. So what I ended up having to do was root the VM. I didn't find a vulnerability in it, but I had to log in and change some configuration. So I did that using a Linux live CD. You pop the ISO into the CD drive, reboot, and you've got a Linux desktop. On the left, you'll see that I could access the primary OS, and that's the file system underneath the product. And then when I checked out the Etsy password file, you can see that the admin user has a custom shell. It's a bin/CLI shell. Hopefully you can read that. And the admin user is a part of the www data group. And then if you look at the bottom screenshot, you'll see www data in the sudoers file has permissions to not require a password. So anyone in that group can run sudo commands without a password. So all I had to do was modify the Etsy password to change the shell, right? So then next time I logged in, I got that bash shell I was looking for, and I could use sudo to escalate to root. So that gave me access to the source code on the file system. So my methodology is pretty simple when I have the source code of a web app. I'm here to tell you don't need fancy tools or anything like that. All I do is I look for vulnerable patterns in the code, and so that's programming language specific, right? So check out OWASP top 10. Like for instance, I was looking at PHP and Perl, so they would have guidance, for what vulnerabilities look like in those languages, and I use regular expressions. Next, I'll look for sources of untrusted input. So that could be command line arguments, HTTP parameters or headers, file I/O. There's all sorts of input. Next, I'll look for unauthenticated entry points into the application. So how can I work my way in without requiring a login or session? And most importantly, make sure you really read that code and understand exactly how the application works. That's what's going to make you successful. So like I said, there are two separate applications. The SDWIN Center is a Cake PHP application, and the appliance, believe it or not, is a Perl CGI. So totally separate. So that means you have to understand the specifics of the framework underneath, right? So Cake PHP versus Perl CGI, they're totally different languages, different logic. The routing's handled differently, the authentication's handled differently, and that untrusted input is going to look different in the code. So like, you know, if a get parameter named ID comes in, they look totally different. So when I was looking at the Cake PHP application, I was looking for something specific, and that's the auth component. If you take a look at the red box, you'll see there's a collector controller class that allows authentication, or excuse me, allows unauthenticated access to all of those various actions within the controller. So I have to say thank you to collector controller, because what I found was that there were vulnerabilities. So I found 5 vulnerabilities, right? They were all, I could only get to them with authentication, except when I found collector controller, I realized that it would forward requests without authentication. So I could reach those vulnerabilities without the auth that you otherwise would need. So on the Perl side, it's a little different. It's not so frameworky. Like in the red, you'll see there's an explicit check for authentication, right? However, I was able to bypass this because they're not checking untrusted input and validating it. So if you take a look, you'll see the SSL client verify header is checked to see what the value is. And if it equals success, then we won't check for auth. So that ultimately, further down in the script, it led to a CVE. So in addition to knowing framework specifics, make sure you know how to identify the unsafe code patterns in those languages. And so these are some examples that actually worked. You'll see the exec for command injection and fopen for directory traversal. And then there's a SQL injection as well. And something else I'd like to hit on is when you're running your regular expressions and checking for patterns in vulnerable code, there's going to be a lot of noise. So you really need to work to tighten up your regular expressions and your patterns to give you exactly what you're looking for. And then once you find those syncs, check to see how the input is flowing into those function calls. So here are some actual hits for the vulns that I found. You'll see in the orange, those are all command injections, as well as the pink. Directory traversal with the fwrite in teal, and SQL injection in green. So just using regular expressions, I was able to find all of these. Ultimately, it led to 5 remote code executions in SDWIN Center. That's the Cake PHP app. And I was able to reach all of those vulnerabilities with collector controller, not requiring authentication. On the appliance side, it was a little more fun. I was able to chain vulnerabilities together. So I exploited a SQL injection in order to bypass some authentication, and then that got me access to exploit a command injection down the road. So it got me root there. If you want to check out the exploit, I dropped a link there. So if you're interested in any more details, like proof of concept scripts, they're all up on our research advisories, and then we have some blogs as well outlining the process in more detail.
All right, I'm going to go over an exploit I found in Zoom. I assume most of you are familiar with Zoom conferencing. This is a critical remote exploit capable of remote code execution as well. And I'll go over a bit of the details here. So first thing this CVE would allow, it could allow attackers to hijack remote desktop feature during meeting, which means you can force control and also send keystrokes as well. You can allow attackers to spoof chat messages to appear from other users in the Zoom chat. It can allow attackers to boot other attendees from the meeting, as well as kill the entire conference, even without being meeting host. And best of all, these were all exploitable, even by a completely remote, non-meeting attendee. So over WAN, you could actually inject keystrokes to another Zoom meeting that's occurring in the wild somewhere. So going over how this worked, this is a Zoom topology. I kind of reverse engineered how it worked. Zoom, the way two clients talk is they'll make use of two channels, a TCP channel and a UDP channel. UDP will be for the audio visual streaming, and TCP will be for more like the meeting relevant status updates. And this is what I call the trusted channel. So this is where it'll say, I'm sharing desktop right now, or who am I sharing it with, or am I muted? That's all TCP over the trusted channel to the Zoom servers. Now, the problem with what I found in their code is, right here, I took apart the part in the client app where it's receiving network data from the server or the client. And they're using a generic class, socket.io, which is abstracting all network receiving data. So what they do is they just call this generic function here that receives either TCP or UDP data, doesn't really make a distinction which one. And they create a message object, like the one outlined here, and they post it to a message pump in Zoom so that it can get processed by the application. And the problem is they're making no distinction if this was a UDP packet or a TCP packet that accepted. So here are like the 4 message pumps that Zoom will make use out of. The one that we're attacking here is actually the events message pump, which is the top one. And when that goes to the message pump, the packet that it receives goes through a switch case to trigger various functions inside the Zoom client, whether it's like share desktop, like I said, or mute, or kick the attendee out. And these are some of the cases that you can hit. And what I realized is that, well, if there's no distinction between TCP or UDP packets, what if I make my UDP packet look like a TCP packet with the correct data in it? So here's a TCP packet that Zoom would accept. And I reverse engineered some of the little components that are important. Like in red here, we have the actual message ID, the function ID, it'll hit in that switch case. Green is showing that it's telling you to share desktop. And the orange and blue are saying which clients to share the desktop with. And in UDP, the offsets are processed a little bit differently when I checked out how it worked in Zoom. But if I pad it differently and supply that same function ID in this byte, and then as well as sharing desktop instruction as well, it'll go through that message pump and be interpreted just like it was a trusted TCP packet. And overall, this is what it'll look like. On the top right here, we have like a malicious Zoom client. Again, it could be not even a meeting attendee, so also just someone that sent a UDP packet to the server or the Zoom client. And it gets processed over here by the Zoom client on the right, goes through the message pumps, gets posted to the events message pump, and then dispatched to the function table that we can hit through UDP packets. And like I say, this could be, hey, share your desktop with me. Hey, accept these keystrokes, run them. And you can basically do all sorts of interesting things with that. So if you want to read more, I encourage you to check out the TRA, the release advisory we put out, as well as my blog that goes over this in much more detail. CET Wells and Medium. And now Joe will talk about Logitech Harmony Hub.
Cool. All right. Yeah. One more example here. I hope these are helpful. Like, it just kind of shows. I think sometimes when you watch other people's work, it's helpful to see how they approach some problem. Like, if I looked at Zoom, I'd be like, nah, there's no way there's a vuln in there. And like this one, Logitech Harmony. I was just looking on Amazon, just like, what's an interesting device? Oh, that one looks cool. Let me buy it and just see if I can understand it and find something. So this device is basically a smart home hub. It just aggregates everything, connects to everything: air conditioning, your refrigerator, your stereo, your TV, home security systems, door locks. And so the first step in attacking a black box for me is just to map out the network footprint of the device. And it's a really easy way, no effort required, just to see what's available from the network. Because it's such a great attack starting point. And then for this device, it looks really promising. There's, like at the top, you can't see it, it's an Nmap scan. So there's 3 ports open, and it looks really good. Weird port numbers, a bunch of services open. And then as it turns out, Logitech implements functionality over a couple of these network services. So it has XMPP for user interaction, and then it has a WebSocket service, which is used for server communication and interaction with the user devices, iOS and Android apps. So all of the functionalities ends up being implemented in Lua code in the firmware of the device. So firmware. Next step is just to acquire and analyze the device firmware to understand what's going on in there. And eventually I found out how the device updates its firmware. This is always a challenge for these IoT devices. Sometimes you can download it online. In this case, I couldn't download it. I had to see where the device is actually querying, and it uses SSL, so you can't just sniff the traffic. But the My Harmony application, this application that you can update this device with on your computer, doesn't pin certs. So you can man in the middle of that application to figure out where it's requesting the update, the firmware from. So you can get a copy of the firmware, step one. And one of the nice things about this device, and it's not always the case, is that the firmware was really easy to understand. It's easy to extract, headers well-known, and file system understandable. So a side effect of using an obscure file system or an obscure firmware type is that it makes reversing it like another 10 or 20 times harder. But anyway, so once I had the firmware for this, it breaks down into a squash file system, a kernel boot image, and then a Linux update binary. And I only needed to, and in this, like for this discussion, I'm only going to explain the file system because it has all of the application code, which is where the vulnerabilities were. So the hub uses a patched version of the Lua 5.1 interpreter, and all the code's stored as compiled Lua, which looks like that on the left. So you could try and disassemble it and understand reverse engineer Lua intermediary language, but it's much easier to just decompile it. And there's some decompilers out there. I had to jump through a few little hoops, like the normal Lua interpreter didn't work because the one that they were using in this device had some patches from the OpenWRT community. And so, but once I got that all going, it was able to decompile really nicely. So in the end, we published 4 vulnerabilities for this. A couple of them were XMPP vulnerabilities that affected authentication, but the really two that were actually interesting and that I'll talk about can be used together by anyone on your network to remote root the Harmony device. So the first one is command injection. And first, let me describe the network flow of the device. So the Harmony Hub communicates with user applications on Android or iOS over the local network, and it communicates with Logitech servers over the WAN. The user applications can also command and control through the WAN too, through Logitech servers. And the hub communicates with a bunch of different Logitech servers, but the command execution exists in the time synchronization code, so we'll look at that one. All right, so time for a source code review. That's probably kind of hard to see, but so line 132 there, the device makes a request to a time server, and then it takes the data from that request in line 137, and then it uses it in line 142 and executes everything on 145. So the patch diff here shows the changes. On the left was the vulnerable version. On the right was Logitech's patch after we reported this vulnerability. And in the patch version, all they did was just add a string match to parse out integers as a way of validating a timestamp. But before that, there was no validation. It just takes the data from the GET request, puts it into a command string, and executes it. All right, so second vulnerability is application command execution. So Logitech makes requests to the device to have it do stuff. And so the hub accepts these commands from Logitech servers over the WAN on this WebSocket service. The handle post function in the device validates the origin of these requests, but it only does that by checking the header, an origin header in the request. So it checks for this myharmony.com string. And the result is that the origin can just be forged. You can just add a header with myharmony.com string in there, and it doesn't matter where it comes from, it'll just run it. So you can basically send it any application commands. And the result is that you can tell the device to contact our own controlled server for a time update, and then trigger that first vulnerability to do command execution. So you have unauthenticated remote root of any Logitech Harmony Hub that's on your network. So you can use that to control just different household devices or security door locks and whatever. Kind of fun one.
All right, so that's all the content we have for you. Open up for questions or comments.
So on the ones you found, you didn't sort of cover your interactions with any of those particular companies. Were they responsive and they fixed them, I assume? Say a little bit more on the Zoom and the 3.
Yeah, sure. I think we all have varied experiences for that. What was yours?
Yeah, Logitech was really responsive with that. Very helpful, friendly, super nice. Like, tons of thank you for finding this. Like, they realized that we don't really have a dog in the fight. Like we're kind of just doing this external research, so they're real helpful.
Did they give you a copy of their code so you could look at non-decompiled stuff?
No, they didn't help me at all.
Yeah, mine for Zoom, I think they recognized the criticalness and they tested themselves and ended up getting a patch out. So that was reasonable too. It was like within a 90-day time frame. So that was my experience with them.
Citrix has a very good product security team in terms of the communication. They were great. They're very responsive when I would send information or request stuff. And however, something we do run into every now and then is a vendor. They're trying to be proactive and patch as early as possible. But Citrix in this case actually patched early and didn't let me know. So we ended up releasing our advisories before the 90-day deadline. That happens quite often.
Oh yeah, that's a good question there. We try to take a balance between prevalence and kind of how maybe vulnerable the target might seem. So for example, like if you want to find like a Microsoft vuln that's really prevalent and can get really good impact if you get it resolved and fixed and report it. But also at the same time there's also low-hanging fruit out there that's a security threat to us, right? So it's also finding things that just seem less secure. Like I've looked at a few routers that don't have the best security. That's another reason that we choose our target. So it really, to answer your question, it's a balance between those two concepts. So I don't know if you guys want to chime if you have your reasons.
Yeah, I would just add that, for me, it's more fun when I figure out what I want to do instead of someone telling me. So like we do have this list of like targets that, I don't know, whenever I look at that thing, I'm like, I don't want to do any of that. And then I just go on Amazon and find something interesting. So there's a motivation factor there to pick something that you're interested in, that you really could see yourself looking at for like, maybe, at least a couple of weeks, maybe a month or something. Just whatever can keep you motivated and pushing through it, because you always hit those roadblocks, and it's good to help you push past them.
Yeah,
I'd like to add in real quick. So like you said, we do have a dream list where it's like, people in the company say, hey, I want you to look at these targets. But some of them are, really reaching for the stars. So like we really do try to look at targets that are meaningful, like I said, like IoT, SCADA, something, if you find security flaws, it's going to make a difference, right? So
yeah, exactly.
And we won't look at Joe Schmo's FTP server.
Yeah.
On the CDs, do you get them? Do you apply for them, or does the vendor apply for them?
It depends.
What's the process?
Yeah, usually it's a policy. It's called CNA. So we're at CNA. So so we apply our own. But in other cases, they might be one, and so we leave it to them to fill the block. Yeah. Yes.
Have you tested a lot of other home automation systems, like Wing, SmartThings,
Yeah, thank you.
We've taken a look at some of them. I can't talk too much about them at the moment.
I don't think there's anything that's currently in disclosure right now, but and a lot of them are hit and miss too. Like sometimes you look at it and just give up after like a couple weeks. Like, yeah, no, this is not worth the time to like take a chip off and dump firmware on it that way. So there's a lot of pick and choose in there.
Have any of the vendors ever contacted law enforcement?
How much can we talk about that? Jimmy would probably tell you a story. Like there are definitely vendors that are just you just scratch your head like, man, what's going on over here? Like they can involve legal and yeah, I mean like
It's rare though.
it is rare, yeah, but it does occasionally happen.
Yeah, we've definitely had run-ins with unhappy vendors, but no law enforcement yet.
Does everyone have their own wheelhouse, or is everyone good at a little bit of everything?
I would say we all have a broad skill set, but we definitely have our own wheelhouses too. Like I come from a development background, so web apps they're my wheelhouse. But I definitely, I work hard to get good at reversing like they do,
Yeah, we have a great assortment of skills, I think, and like you said, there's a lot of overlap, of course. But like we found that some people like really focus on hardware, and like I don't pride myself in hardware, And so they do more of that, and then others like are more like reversing or web apps. So it's a overlap, but also definitely specialty when you get down to the details.
You got any that you were like 3 weeks in, you're about to hit the vendor up on this whatever, and they published the CD because somebody beat you to it? Does that happen much?
I have one like on that I found, and it was weird. I won't mention the company, but I found one, and the internal devs already found it, but they found it, but didn't talk about it. And so by the time I reported, they said, "Oh yeah, no, we had a CV for this whole time, but it was like not listed or anything." So that's happened to us before. I'm sure you have some experiences too, and we all do.
Yeah, or like related vulnerabilities too. Like, we've reported some before that the product has actually, the vendor has a security team and they take it and run it and find like 2 other things, and we're just sitting there like, how do we miss all those?
There's a great white paper you can read on this that talks about the overlap of 0 days and the likelihood. Like, I think it's like, 0 days, 1,000 nights? I think it was put out by Rand, I think, and it actually goes over the likelihood of like when you're finding a 0 day, how likely it is to collide with another. And the study was actually the shelf life or whatnot is actually quite long. So, yeah.
Yeah, and actually to touch back on that, our team was kind of born out of that mantra. Like if we find bugs, someone else will too, right?
Have you ever experienced finding a bug with some companies like hardware and realizing that the same vulnerabilities across their whole product line?
Yeah, so, and there's a couple other ones that we haven't really published yet that exact thing has happened, like firmware decryption keys, for example, where it's literally like you realize that they use it across their entire product line. So it's definitely things happen like that, for sure.
Would you say that you find bugs more effectively by looking at code or by running it in the tools that you mentioned? Because I think Jimmy and Chris seem to have their own opinions there.
Yeah, I'd say for me personally, I tend to stick more with reversing and not so much automation and tools. I think it goes back like one of the themes that happen when we talk about our case studies, I think we'd all agree they were all logic flaws for the most part. And I think tooling for some of those might be, of course, like scanning for code, but I guess I'm more talking about fuzzing in that case. But I personally like reversing and taking it apart and actually spotting it when I can. But I think, others like tools or...
To be honest, I don't use any tools really when I'm looking at, if I have the source code, no tooling. I just have patterns that I'm searching for. It's just being familiar with that language and what a vulnerability might look like. Fuzzers definitely have their place in automated tooling, when you're looking at something very complex. But for the most part, I like doing it manual.
Have you ever worked on something and you couldn't figure anything out, and then a few weeks later, another company or another team figures it out, and you just sit there looking at it for some fix you thumb up your face?
Yeah, that's always why I try to make sure I don't move on until I find something. But yeah, that's painful. I think it's happened. Actually, it did happen to me recently somewhat. And yeah, it happens. That's why sometimes the code, the reality is sometimes some of these programs are so big and wide, you had time to look at one particular part, and you just gotta say, this is the part I exhausted and I moved on. Maybe someone else looked at another part and found it. So part of it is just the nature of it, and it happens, but it's nothing to beat yourself up over.
I had that specifically happen. I was looking at the Verizon Fios router, and I found some bugs in the web interface because, that's my wheelhouse, right? But then a couple months later, another research firm found remote code execution in the UPnP service. So he looked at a different component, found a better bug than I did. But it happens for sure. Go ahead.
How do bug bounties get handled? Do you guys get to keep them? Does your organization decide what to do with it? How does that work?
I can answer that. So, yeah, for the beginning of this team, we were allowed to collect bug bounties. And It was kind of nice. We could submit to ZDI and just take that money too. And I think somehow our CEO caught wind of it and shut that down. But individual bounties, we can still collect them. We just can't submit them now to ZDI. So yeah. But we try not to let it affect target selection.
As Tenable Associates, so what's the company's end goal out of this?
I think it's like general disclosing bugs, like in order to fix them, going through a disclosure process like this. So really making devices more safe, and as well as updating our own scanners so that we can find more things, and also just awareness and building more a bridge between other researchers and stuff in Tenable. So I think that's.
Do you guys want to Nessus scan and find bugs right away?
We don't, but the guys that do work on Nessus plugins, they will occasionally get reports from customers and stuff saying, hey, your scan broke our stuff. There might be a bug here, so they find bugs like that sometimes.
Yeah, that's pretty rare. I don't think that's really happened too often, maybe once or twice. And the other thing is like, we also red team kind of like our own product stuff that we use. I don't know if that's the right term, but like Slack, for instance, and Zoom, we use that in our company. And so that was one of the reasons why David picked it up. It was on our list of stuff to use. It's like our company uses it. Let's see how safe it is. So.
Any more questions? Sure.
You talked about looking for certain patterns just in your manual analysis. Have you thought about either encoding those into a static analysis tool or figuring out like things that pass the grep that would help you find those more easily?
Yeah, I'll tell you the truth. I do have sort of my own static analysis tool, but it's basically just a big, so for each language I'll have patterns that I like to look for. So I have a PHP pattern list, I have a Perl pattern list, and so yeah, I do compile my own static analysis, pattern sets, but it's not much beyond that. For the most part, I find bugs, really through reading the code and just making sense of it. Like for that header one, that's going to be kind of tough to find with a pattern, So kind of look around the authentication mechanisms and trace the input into, the patterns you're looking for, and that's what I do. Does that answer your question?
To follow up a bit then, so when you say patterns, you might not be talking specifically about code patterns, or like how the program is structured or how it's accepting input.
So I'll start with, I'll call it a sync, right? I'll start with a vulnerable function. Say I find a system call, right? So I'll go to that system call, and then in my pattern, I'll have a check to see if it's processing a variable. And if it's processing that variable, then that's of interest to me. I'm going to look at it, check the code above it to see how that variable gets processed. And if it comes from some untrusted source of input, like a get parameter or whatever, then I'm going to hammer that hard and really look into it. So I start with that pattern and then read the code from there.
Excellent. So thanks guys for coming. We're open. Thank you. And we're open for more questions. Catch us in the hallway, wherever you see us in the con, and we'll be happy to talk more. Thanks.